Dear students, today we'll learn the Greibach normal form. We all know that CFG context-free grammar and the concept of grammar is prerequisite to learn the Greibach normal form, which we have already discussed in the classroom. So let us discuss the Greibach normal form. We can define the Greibach normal form. In short, we can call it GNF also. Every context-free grammar without empty production is said to be in GNF if every production is in following form. You can clearly see the production number 1. A non-terminal drives a terminal followed by a string of terminals. Here small a terminal. The length of this terminal is 1 only. Alpha is a string of non-terminals. In other words, we can also say that context-free grammar is in GNF if all the productions are in two forms. First, a non-terminal drives a terminal followed by a string of terminals. You can see over here, A drives small a, capital V. Or we can say that a non-terminal, single non-terminal drives a terminal. Then the CFG is said to be in GNF. I hope I make my point clear. It is also very important to understand the application of the topic. It will help you to connect with the topic. GNF is very important topic in theory of automata and formal language. By understanding the concept of GNF, we can easily learn that while driving any string, which will be the first symbol to be derived using any given rule, because it is in the definition of GNF. The second very important application of GNF is GNF will be used to construct the push-down automata that recognize the language generated by a context-free grammar. We will discuss the push-down automata in the next unit, and the videos which we will discuss in the next videos also. So now another related topic will be discussed over here, left recursion. I am very sure about that. All of you have learned the concept of recursion in first year while you were studying the C. So here also the meaning of recursion is same. I think you are aware about the recursive functions. Recursive functions are those functions which call itself. So here we can carefully establish the analogy between the left recursion and the recursive function. A production P1 is said to be left recursive if it is in following form. A drives capital A alpha. So clearly see here, A is what? Non-terminal variable. And A is the leftmost symbol on the right hand side. So whenever this production is used to drive any string and we will replace A, then this production will call itself again and again. And you can see that if we have not handled this problem carefully, it will be a never-ending loop. So this kind of production is said to be suffered with left recursion. So it means, let me summarize again. A production is said to be in left recursion only when a single terminal drives itself followed by any string of terminal or non-terminals. So this is the concept of left recursion. And as I told you, it is very important to remove the left recursion while we are handling the grammar. So now in the next slide, we will learn how to remove the left recursion. See here, it is important to remove the left recursion during the replacement process. The left recursion can be removed by the following scheme. First, so in first part we will discuss a specific production. In the second part we will discuss a generic case. So let's say the production is in following form. A drives A, alpha and beta. In production 3 you can clearly see that. So from the definition it is clear that this production suffered with a left recursion. Why? Because A is calling itself. When this production will be used for the replacement process to generate the string. So again A will generate A alpha and this will create a left recursion. So how to remove that? To remove the left recursion, we have to rewrite this production again. And we have already discussed in the classroom, in case of TFL, the language should not be changed. So only we are rewriting, we are not changing the attribute of the production. So how to rewrite a production? We will introduce another non-terminal A dash to rewrite this production 3 in the format of 4 and 5. Let us discuss. So here we introduced another non-terminal A dash. Now A drives beta A dash and beta, and the non-terminal which we introduced A dash drives alpha A dash and alpha. So if we write 3 into form of 4 and 5, so you can clearly see that the left recursion has been removed and the attribute of the production is also not changed. So here A dash as a new non-terminal has been introduced to remove the left recursion. This was the very specific case. In the next slide, we will discuss the very generic case. So in general, your production may be of the following form. You can see the production number 6. A drives A alpha 1, A alpha 2 up to A alpha m, and beta 1, beta 2 up to beta n. This is the general case of the case A. Now we will introduce a non-terminal A dash, and again the same analogy will be adopted. We will rewrite the production 6 in the form of 7 and 8. You see that A drives beta 1 A dash, beta 2 A dash up to beta n A dash, because there was, how many betas was there? Beta 1, beta 2 up to n. So we write the n cases, again beta 1, beta 2, bn. Now A dash, the new non-terminal, drives alpha 1 A dash, alpha 2 A dash up to alpha m, because in production sim 6 there was m alphas, and alpha 1, alpha 2 and alpha m. Now production 6 has been rewritten in the form of 7 and 8, and this production 7 and 8 is free from the left recursion. So this is how we can remove the left recursion. So you will have a curiosity that why we are learning the removal of left recursion. See, we will discuss in the next lecture when we will discuss that how to convert a given CFG into form of GNF. So it might be the case some of the productions may suffer with the left recursion, and as I told you, not to confuse the compiler is a better way to understand the TFL. So when you are writing a language and you have to be very specific, your production should not suffer with the left recursion. That is why we learn the left recursion. Thank you very much. In the next lecture, we will learn how to convert CFG to GNF and algorithm to convert the CFG into GNF. Thank you very much.